Hi, welcome to another episode on very short answers question from nanotechnology. What are the nanomaterials? Nanomaterials are the materials with the dimensions in the nanometer range. So typically, if it is between 1 to 100 nanometers, those materials what we call nanomaterial. Then what do you mean by quantum confinement? Confinement of the electrons or holes within a nanoscale structure like quantum dot or nanowaves. So when the dimensions of the structures are smaller, in the order of wavelength of the electrons or holes, their motion becomes quantized and discrete energy levels are formed. That's what we call quantum confinement. So quantum confinement means based on the size of the particle or size of the material at a nano level, the energy level will change. That leads to formation of these discrete energy levels, and this is the reason behind the unique electronic and optical properties of the nanomaterials. So, as an example, in a quantum confinement, we know that when the size of the nanoparticle changes, its color will change. Then, next one is surface to volume ratio of nanomaterials. This is another crucial one. So basically, surface to volume ratio, whenever it increases, automatically it increases the reactivity and surface sensitivity in most of the applications like catalysis and sensing. So when we take a bulk material, its surface area is fixed. So when we make it into small parts, what happens is the hidden surface also exposed to the or surroundings. So the reactivity of the material goes on increasing. Then what is the applications of XRD? XRD stands for X-ray diffraction, and X-ray diffraction technique is based on Bragg's law. We are very much familiar with it. It's nothing but 2D sine theta is equal to n lambda, and in this D is interplanar spacing, theta is the incident angle, n is the order, lambda is the wavelength of the incident rays, typically X-rays. So what are the applications for XRD? XRD can be used to determine the crystal structure, then identifying the unknown materials. Then it is used to characterize size, shape and orientation of the crystals and the strain and defects in the materials. Then what is the distinction between XRD and TEM? XRD is typically used to determining the crystal structure, whereas TEM is useful for studying the atomic structure and defects in the materials. So both techniques provide the valuable information about the structure and properties of the materials at the nanoscale. For bulk materials also we can do for XRD. For TEM means we have to make a sample very thin. Then if we want to go into deeper, what is main difference between XRD and TEM? If it is asked for 1 mark, up to here that's sufficient. Say the same question is asked for 5 marks or 10 marks, you have to explain more. So XRD stands for X-ray diffraction, TM stands for transmission electron microscopy. So both are analytical techniques used to study the structural properties of the materials at atomic and molecular level. XRD is based on a diffraction, whereas TEM works through transmission and the interaction of the electrons with the materials. That will provide the information. Next, come to the sample preparation. XRD requires a powder sample or single crystals. Sample preparation is very simple, but when come requires a thin samples that can transmit electrons. So sample preparation is a huge process in case of the TEM. Then information what we will get: crystal structure, lattice parameters and crystal symmetry. From XRD we will get. TEM will provide information on morphology, crystal structure, defects in the materials. Then when come to the resolution comparatively less for XRD, and TEM it is a atomic level resolution we will. Then limitations is, so it is not so, XRD is not suitable for amorphous or disordered materials. TEM can only study thin samples and is limited by damage caused to the sample by electron beam. In a TEM we will use high energy electron beams. Then what are the any 3 applications of nanomaterials? So there are many applications of nanomaterials as well as nanotechnology. When come to the electronics, nanomaterials are used in the production of electronic devices such as transistor, memory chips and sensors due to their excellent electric and thermal conductivity. And in the medicine also it will be used, such as drug delivery, bioimaging, tissue engineering. So many places we can use in the medicine. Not only there, we can use these nanomaterials and nanotechnology in energy sector for production of solar cells, fuel cells, and batteries. So due to high surface area and excellent electrical conductivity. Not only that, we can use these nano based materials in environmental things also. Basically, it is used in the treatment of a wastewater and reduce air pollution and environmental remediations. They can be used. Then food and agriculture we can use for packing, food processing, and crop protection, fertilizer protection. So many places we can use. Not only there, textiles and aerospace, like that in every field we can apply these nanomaterials. So that's all for signing off. Dr. Shivanagi Reddy, all the best for your exams. Jai Hind.